Thank you, everybody, for joining on this wonderful Saturday morning. This Green Energy series, we're going to talk about a tool that PNL developed that will really help homeowners work with the contractor and help contractors get high quality retrofits into people's homes. And then as a homeowner, you can ask your contractor to use this tool called the Quality Install Tool. And that will help your contractor go through the steps of documenting the work done on your house and ensure that it's done to a very high quality manner. And so before we dive into that, just a little bit of a recap on Solar Oregon. Solar Oregon's a nonprofit that's been around for over 40 years. Its mission is to do education, outreach, community, and advocacy work around solar. And in the last few years, it's been a solar plus storage effort because if you've listened to other Solar Oregon presentations, we really encourage the importance of storage to go alongside solar. Some of the main events that we do is solar tours. In October, we completed a green Go Zero home tour where a handful of homes that have done a bunch of work on installing solar and energy efficiency retrofits into their home. We're on the tour. We do solarized campaigns and we do peer-to-peer education such as this Green Energy series. If you like our work, feel free to, we really encourage you to donate to Solar Oregon. We are a lean and mean small organization running on a fairly small budget, but some of the work we do is not completely zero effort, zero cost, I mean, and so some of your donation will be certainly appreciated. And this webinar, feel free to use the Q&A tool to ask questions. And about me, my name is Edward Louie. My Monday through Friday job, I work at Pacific Northwest National Laboratory as a building energy efficiency research engineer. And you can find a lot of my posts about musing on building science and various aspects of energy efficiency and sustainability on my LinkedIn. I encourage you to follow me on LinkedIn. And I'm also building a near passive house, off-grid tiny house, where I use that project to test various high-performance building products and assembly techniques, such as importing high-performance windows from Poland. It took a while to get those windows, but that was very successful, and I got them at a fantastic price, and encourage more people to pursue that path of getting high-performance windows from European countries. As a disclaimer, this presentation does not necessarily reflect the position of Pacific Northwest National Laboratory, U.S. Department of Energy, or maybe even necessarily Solar Oregon, but best effort has been made to convey facts and information accurately. So about this quality install tool, it is a free, easy-to-use tool that has many workflows that cover the commonly done residential retrofits. It was developed by Pacific Northwest National Laboratory. I had a hand in taking the lead in the development of this tool. And the funding of this tool is from the U.S. Department of Energy. So if you pay federal tax dollars, this tool is free for you to use because, well, thank you for paying your federal tax dollars to support work like this. The quality install tool is available. You can find it on Google. If you search quality install tool or PNNL quality install tool, it should appear on the first page of Google. So the problem we're trying to solve is with this tool is that a lot of times residential energy efficiency measures are not installed correctly, and they leave energy savings and dollar savings on the table unrealized. And the problem is shockingly severe. A lot of attic retrofits are, especially the low cost bids that seem like, wow, this is a good deal. Like if it seems extremely affordable, maybe that contractor is cutting some corners, meaning like that they're not doing any air sealing in your attic before they put more insulation into your attic. And that's what's called a blow and go insulation job. It's done very quickly and it's very easy for the insulation contractor to do. But unfortunately, all that additional insulation that's installed in your attic does very little good, because if there's air going through your attic from all the gaps and cracks in your ceiling, that air moving through that fluffy insulation they blow in results in the insulation being very ineffective. And so it seems like you got insulation, but its effectiveness is not good. Same thing if you insulate your walls. If there are small gaps in the insulation in the walls, you can lose a lot of the performance. On the mechanical, HVAC side, if you have some faults in your HVAC installation, such as poor airflow, and this happens all the time, many homes have ducts that are not very high quality. And so then by just replacing the mechanical equipment from like such as a furnace to a heat pump, if you're not looking at the ducts and trying to improve the airflow of the ducts, you end up with poor airflow, and then that results in the heat pump working really hard and not actually being able to deliver that heat or cool that it's producing. And so these faults, such as low airflow and incorrect refrigerant charge, can result in our nation as a whole having billions of dollars in additional energy cost. And this is not just hypothetical. We know that these faults are common. And they certainly have the greatest impact on low-income households who are trying to really count every dollar and make every dollar go as far as possible. But even if you're not low to moderate income, you certainly want the energy efficiency retrofits that you paid for to deliver the goods that's promised to you, right? So it makes sense that it's should be installed in a high-quality manner. And in addition to the energy savings elements, we also need to address climate change. That's a lot of reason why we want to install energy efficiency retrofits is that it's more comfortable. It certainly saves energy, but there's also a need to decarbonize our energy and buildings. And if we don't install these energy retrofits into homes in a high quality manner, we're not going to realize the energy savings, and therefore we're not going to realize the carbon savings. And that's a big problem. I mean, if you really think that climate change is a big problem, then quality installation should be prime on your radar. So how is a lot of energy efficiency retrofits, if it's part of an energy efficiency program, such as your Energy Trust of Oregon programs or other programs, how are they typically quality inspected these days? A lot of these programs run on a in-person inspection, and they randomly select about 5% of the projects, and they for each contractor, and they inspect those jobs. And then if they find problems in those jobs, then they will the inspector or the verifier will ask the contractor to come back and fix those problems. But you as the homeowner, you need to schedule time for this inspector to come on site, because they don't want to come to your home when you're not home. And then so you need to take time off work or whatever to make time for this inspector. And then if they find something and the contractors come back, then obviously you need to be home as well for the contractor to come back and fix these issues. So it's a lot of inconvenience and time spent. And then prior to my job at PNNL, I used to be a verifier for programs, and I spent hours each day sitting in traffic and driving around town from one job site to another. So I can tell you that there's some inefficiencies with this process of in-person inspection. And the other kind of thing that's really most problematic about in-person inspection is that we don't dig through insulation to look at air sealing details, for example. And when it comes to HVAC equipment upgrades, there's things that are hidden and impossible to verify after the fact. And so if there's no documentation or proof that it was done correctly in the beginning, there's no way to know afterwards. So what can we do instead? Well, a lot of we have smartphones now, and these smartphones have very good cameras. And in addition to having a very good camera, they also have a GPS. And so you can take GPS, stamped or geolocated photos that are also time stamped, and it's very convenient for the smartphone to be able to do this. And so PNL developed a tool that utilizes these features in modern smartphones and created workflows that have photo prompts, such as, for example, take a picture of the outdoor unit of your heat pump, take a picture of that nameplate, that photo prompt, and then you take the photo and it automatically geolocates the photo and it puts a timestamp on it, and it automatically creates these PDF photo reports so that all the photos are properly sequenced with some text to give it context, and that the photos are all resized and rotated correctly on the page, so that these PDF reports are automatically created, and therefore the contractor doesn't need to actually go back to the office to download the photos off their phone and go into Microsoft Word and like create a report for you. Like, it's automatically done. And then once the PDF then lives on the phone, it's very easy to use the sharing features on a smartphone to be able to email it out to the customer, to the company's data repository, the office manager, and then also if the home gets selected for verification, it's very easy to then send this photo documentation of quality to a verifier to review. So it's a much more easy and streamlined approach. And then if you're a verifier and you run a program that utilizes this quality install tool, then instead of driving around town from one house to another to inspect in person, you can just sit at the office and verify by looking at these photo reports. And that's a lot less driving, saves a lot of gas and better for the environment. And that way, perhaps you can, instead of spending hours sitting in traffic, you can verify a few more reports in the day and, have a higher verification rate. So that's also good. So I've alluded to kind of who benefits. So as a customer, having a contractor document the work in a standardized way means that there's no corners being cut. These quality installation workflows are based on industry best practices and other standards, and so they were not the workflows were not designed in a willy-nilly way, and so as a customer you get high quality retrofits on your home. On the contractor side, it helps ensure that the work, there's no question later down the road that what the level of quality of the work that was done, because you now have photo documentation from start to finish. So it's a kind of a litigation risk reduction tool. And then as a company owner, we've also talked to many contracting company owners, and one of the challenges they face is when they have new workers, how do you train those new workers and ensure that the work that they're doing is high quality when you can't be there watching over the shoulder of these new workers all the time, especially if you hire multiple people. You can't be in multiple places at the same time. And so by having all the workers use the quality install tool, then the work they're doing is the critical details at each step is being photographed, and the boss can look at those reports and be able to use those photos to evaluate the quality of the work of their workers, and then also use them as in-house training material. So there's also many useful ways that the contractor can use this. Many contractors have said that by using this tool, they are able to reduce their rate of callbacks on jobs. And so then that saves them a lot of money by not having to return to a home for free and to fix things. As I alluded to, third-party verifiers can not have to drive from site to site, and they can see more of the work at its various stages using these photo reports. Utilities, by having higher quality energy efficiency retrofits done in their program, then their deemed savings, which is like their assumed savings for each job, can be actually much closer to the full level of savings that is possible for that retrofit, instead of having to take a percent off based on the assumption that some of them aren't done well. And then in the future, perhaps in homeowners insurances can the adjusters can look at these photo documentations to assess accurately the level of risk that this home will have, a unexpected HVAC failure or an unexpected, water leak, for example, based on the quality of the installation of the water heater or a heat pump, for example. And so potentially in the future, homes that have photo documentation of their energy efficiency upgrades might get lower homeowners insurance rates. So some of the features of this tool is that it streamlines the documentation of energy efficiency retrofits. It covers a wide range of energy efficiency retrofits. So like there are other apps that are like, for example, HVAC focused. And so then HVAC contractors will use that app, but then plumbers may not use that app because it's not really designed for plumbers. This tool kind of covers all the trades, from insulation to plumbing to HVAC to electrical. So it's a kind of one size fits all the tool for everyone to use. There's not even a need to download an app. This works off of the web browser of your smartphone, so it doesn't matter whether your smartphone uses Chrome or Safari or any other web browser, it will work. And that's good because we've heard from contractors, they're like, our phone has already like 100 apps on it. We don't want another icon. So if you could work off of not needing to download another app, that'll be wonderful. So we made that happen. It automatically generates PDF reports, and those photos are geotagged and timestamped, which is important because we've heard stories that, in the past, programs that required photo documentation, some unscrupulous contractors will try to cheat the system by reusing the same photos over and over again. So by having geotagged and timestamped photos, there's no risk of that happening. And again, it's free for everyone to use. So there's that element as well. And so here are the workflows that are available on the quality install tool today. These workflows constantly get refined a little bit more, each week, and as we get feedback. But they're already at a level of refinement where they are usable. If you are a contractor listening to this webinar and you want to use it and you find that certain elements of a workflow doesn't work for you, feel free to email the Pacific Northwest National Laboratory. When you search the quality install tool, there's also a website that has an email that you can email feedback to for this tool. But we feel like we're at a point where these workflows are usable, and that's also the feedback we've gotten from some of the early day contractors who've utilized these workflows. And as I said, the workflow is really also good for in-house training, and then also the photo prompts. So we have photo prompts, but then there's also these collapsible sections that if you're not sure what that photo prompt means, like if you're not sure, if you see the photo prompt vacuum decay test results and you're not sure what we want or what the app wants, then you can open these collapsible sections and then get a few more sentences that describe what the photo requirement is. And this type of kind of prompt also really supports the training because, like, for example, vacuum decay test results, that is something that's already spelled out in the ACA, or Air Conditioning Contractors America, quality installation specification that was written in 2007. However, even to this day, the number of HVAC contractors that have the training to do a proper vacuum decay is still not ubiquitous. And so we want to go from like not ubiquitous to 100%, success with every contractor in HVAC being very successful at doing vacuum decay testing. And so the photo prompts and the photo documentation can help support this training. So when you first visit the quality install tool, you're greeted with a page that looks like the one on the far left. And then when you add a new project by filling in like your project name and address and stuff like that, then you're taken to that third column photo there. And then you can click on that project, and then it'll take you to a list of the retrofits that are available, these retrofit workflows. And then when you subsequently visit this website, it'll remember all those jobs. And so then when you visit the website the second or third time, then you're going to start with what looks the view from the third column. And then you can always add new project. As you can see in the upper right corner, there's a way to add a new project to continue to use this tool. So now we're going to kind of talk about some of the photos that, if you're a contractor, you would take, and then if you're a homeowner, you should expect to see, if your contractor uses this tool. So we're going to go through an example using the attic air sealing insulation workflow, and then we're also going to go through the ducted heat pump workflow. Why we're showing these two workflows as an example is because we think likely that these are some of the two workflows that would get used the most often. But also they really demonstrate kind of like some of the types of tests that are necessary to be done in order to ensure that like attic insulation air sealing is done correctly and heat pumps are installed correctly. So that's why we want to show these workflows. So we're going to get going on these. Make sure that get to the point that we have time for a question and answer session. So with attic air sealing insulation, before you even go and start applying air sealing and insulation products to the attic, we want to have an idea of, okay, just how leaky is this home to start with, so that we can, measure the level of improvement that is made from the attic air sealing insulation. So that's why we want an existing condition starting blower door. And a blower door test is a way to measure how leaky a home is in a standardized manner. What it does is it pressurizes your home from compared to the outside to 50 Pascal, which is a very small pressure difference, but enough to be able to measure the level of leakage it takes to maintain that pressure difference. So we have starting a measurement of how leaky the home is. And before we start doing air sealing insulation work in your attic, we certainly want to make sure that there isn't some health and safety things that need to be taken care of first. Most importantly, like we want to make sure your roof is not leaking, because if your roof is leaking, you should call a roofer to fix the roof first before doing air sealing and insulation work in the attic. Same thing with mold and moisture. You don't want to seal in mold into a home. It'll make indoor air quality from not good to very bad. And so if there's mold and moisture problems in the attic, that needs to be taken care of first before continuing to improve the attic. So there's those prompts to have the contractor look out for those things. And then based on that starting blower door value, we can start to have an idea of, okay, well, if your home is super leaky, what's the chance that, just efforting to seal the attic, that you're going to get to the level of tightness that's tight enough we need to have mechanical ventilation? The answer is probably not. You're going to be a lot tighter than before and a lot more energy efficient, but you may not be so energy efficient that you need mechanical ventilation. However, if your starting blower door value is like, for example, I don't know, 9 air changes per hour, then there's a chance that, by doing the air sealing and insulation work in the attic, you're going to get a level of tightness that you will start to need to use mechanical ventilation to ensure that the indoor air quality stays good. And so that's why in this workflow, in the early part of the workflow, ask about mechanical ventilation and ask the contractor to consider mechanical ventilation if that's necessary. And so that the level of mechanical ventilation is determined using a tool called ASHRAE 62.2. That's a standard for calculating the level of mechanical ventilation a home should have. And there's a tool online called RedCalc that, is shown on the far right that makes it easy for a contractor to pick the the geographic locations, such as like Portland, Oregon, put in the floor area, number of occupants and stuff, and it'll calculate the level of mechanical ventilation that you would need if you were able to seal the house to a certain level. Okay, so when you start getting to air sealing, now notice that the air sealing tab happens first. And that's because you really don't want to do any insulation work into an attic without air sealing the attic first. Because as I said in the beginning, if you don't air seal, then air will move through that insulation that you blow into the attic and then reduce the effect of that insulation dramatically. And so it's very important to air seal. And air sealing has a major effect also on comfort as well. And so some of the critical details for air sealing, like the ones that have the most impact, are in these photo prompts. So like the drywall to top plate, so air leaks from this gap because oftentimes the wood is not perfectly smooth, and so that when the drywall is mated to the wood, then there's some gaps and cracks for air to move into the attic. So we want those sealed. The soffit of the home is really important for attic to maintain your attic ventilation, so that in the summertime your attic doesn't get too hot. And then also in the wintertime, if there's ice and snow on the roof, this ventilation keeps the roof deck cold enough so that you don't develop an ice dam. But that ventilation, if it mows through the fluffy insulation near the soffit, then it'll render that insulation in the perimeter of the attic pretty much useless. And so that's why there needs to be an air baffle to direct that air above the insulation. So that detail is often done not well or in a high quality manner. And so we want to get a photo of that detail to be able to check the quality of this attic soffit air baffle. So here's an example right here of one that's done well. You can see that attic baffles are installed, but then they installed a bag of, so what they do is they put a fiberglass bat inside a plastic bag, and then so that the plastic bag is a air barrier, so that air cannot go through that fluffy fiberglass insulation. And then they roll it up and they shove it into that soffit area, and then so that forms a plug or an air barrier, so that when the insulation gets blown up against that attic baffle, that no air can come through the insulation. So recessed lights is another location that is very common for air to leak through. Traditionally, these recessed lights were air sealed using like a cardboard cap that is placed over a recessed light fixture from the attic, and then they then spray foam around that cardboard hat to create the air sealing. But increasingly, you can kind of kill two birds with one stone using what's called a LED retrofit kit for recessed lights. And so if your recessed light doesn't have an LED already, you can install one of these LED retrofit trim kits, and it will be an LED light, but then notice that it also has that little gray foam gasket. So that gray foam gasket, it will air seal this trim kit against the recessed light can fixture, and the springs holds it tightly against the drywall and forms the seal. The face of this LED kit is completely air sealed. There's no gaps or cracks between the LED emitter and that trim kit. So that's a good way to air seal recessed lights. If the attic has chimneys, that's another tricky area for air sealing, because the chimney, if it gets used, gets very hot, and you always have to assume, even if you don't use your chimney, if you sell your home, there's a chance that the next person who buys the home might use the chimney. And so that's why you have to treat all chimneys as if it were to be used. And so then the air sealing details around this chimney that can get hot is tricky. And so this picture shows metal flashing and what's called fire caulking, which is a high temperature, safe air sealing product. And so that's a good way to air seal around the chimney. And then mineral wool or rock wool insulation is then wrapped around the chimney so that when the insulation is blown into the attic, it can abut this rock wool insulation, but the blown insulation will not get super hot because it's protected by this rock wool, and the rock wool can handle the high temperatures. Same thing with hot flue pipes. You need to have a separation so that the blown in insulation does not contact a hot flue pipe. And so here's a picture of an insulation dam that is placed around a hot flue pipe. Wire and pipe penetrations. These electricians are not insulators or air sealers. And so even though when you hire somebody to install or change an electrical circuit, you would think that might carry a little can of foam to spray foam their holes after they're done, but that often does not get done. And so if your home has ever had electrical or plumbing upgrades or changes, excuse me, it's very common for these to be unsealed. So that's one way to seal it. But if you have rough, what's it called? Boxes, electrical boxes in the attic, often insulation companies will air seal the wire coming out of these electrical boxes, but the knockouts that don't get used are a location where air can continue to move through, as you can see. And so it's really important for an insulation company to spray foam and air seal the entire electrical box and not just the wire coming out of them. Many homes have soffits, and in older homes, there was an era when it was common to build these soffits with no air barrier on the attic side. And so when you're in the attic, you can see and actually reach your hand into the soffits. But that also means that air can go through the soffit and go into the attic. And that means the conditioned air inside your house can also leave through these chases. And so when air sealing attic, it's important to air seal and create to create this air barrier around the soffits. And that's often done by cutting a piece of drywall or wood or foam to cover this opening and then air seal around the perimeter. Ducts. If you lift off the supply grill in your ducts, there's a good chance you might see a gap between the supply boot and the drywall. Or if it's located in the floor, a gap between the supply boot and the subfloor. You can go look at it after this webinar and see if you see this in your home. But this is quite common, and this perimeter is not air sealed, and it should be air sealed. And if you're in the attic, that's how you do it. You spray foam around the perimeter. Exhaust fans. Exhaust fans also have a lot of electrical knockouts and screws and other things that, necessary to assemble and build the exhaust fan. And those holes and knockouts are not air sealed. The best way to air seal an exhaust fan is actually build like a foam box around it and then air seal the foam box. But in your home, if you wanted to do some air sealing this Saturday, you can pull down the cover of your exhaust fan and see if there's a gap between the drywall and your exhaust fan, and spray a line of spray foam around that perimeter, and that will get you about a 50% improvement in air sealing. It will not be as perfect as this solution here, but it's better than nothing. And the savings you get from the air leakage reduction is pretty significant. So knee walls is another kind of common problem in attics. And you would think, one of the questions is, why weren't these done when the house was built? And the answer is that these are kind of the tricky areas in an attic that are not easy to do correctly. And since people don't live in an attic to look at it, well, often somebody took a shortcut or they just didn't know better. And so that's why, these areas aren't air sealed and insulated correctly. And hence why the retrofit work needs to go back and make it good. And so, as I said, it's similar to kind of that top plate photo earlier in the presentation, the knee walls also is an area where the drywall and the top plates, when they meet, air can escape through that gap, and so you need to seal that. Here's another photo from new construction of kind of whenever you have like sheathing, whether it be OSB or plywood or drywall, when it meets framing, it needs to be air sealed, and so there's pictures of air sealing of the top plates. Here's photos from new construction of air sealing of sheathing goods as it meets framing members. The air sealing of the sill plates, same thing. Your knee wall, it needs to be air sealed both the top and the bottom. Here's an example of, instead of using foam, it's using some spray on caulking. That's also an option. It really doesn't matter what material you use as long as you do the air sealing. Here's an example of a knee wall that once the air sealing has been done, there's insulation netting that was installed in order to get so that when the insulation that's blown on the attic floor, they are also able to blow the insulation into the knee walls and get that knee wall insulated. Skylights are another tricky area of a tricky wall that is poorly defined, in construction. And so oftentimes the framing around a skylight is not properly air sealed or insulated. And so in order to do that, again, air seal the perimeter and then later put on insulation. And so sometimes I showed an example of insulation netting, and then the insulation will be blown in afterwards. Well, if you have a framing that is not on the thick side, but on the flat side of the wood, then you only get 1.5 inches of area to blow the insulation into, and that's not enough. So what you can do is then actually enclose the skylight, the wall with rigid foam insulation that's maybe 1 inch or 2 or 3 inches thick, and then you get the R value of the rigid foam, and then you can also still poke a hole through this foam to blow the 1.5 inches that's between the framing and the drywall. So that's one way to do it. And another way that some companies do it is that they just think, well, these areas are so tricky to air seal and detail, we're just gonna come in with spray foam and spray foam the entire tricky area, and therefore it covers the insulation and air sealing requirements. So that's another way that can be done. It's more expensive, and you need to have a spray foam rig in the truck, and not every insulation company has a spray foam rig in the truck. Balloon walls is another type of framing practice that's very common in older homes. Sealing the missing top plates in balloon walls is important, not just for energy efficiency, but it's also a very important thing to be done for fire safety, because these balloon walls sometimes connect the crawl space all the way to the attic. So if your attic is on fire, then these balloon wall chases will actually draw air from the crawl space or basement and continue to fuel that fire with oxygen. And so that's why during the attic air sealing and insulation work, it's really important to seal these as well. Once in a while, you get an attic, a staircase, or a staircase that goes to a attic that's been converted into a living space. And these staircases often have walls that kind of transition from conditioned space into unconditioned space, and they're very tricky in terms of where to air seal and insulate. And so the original remodelers did a bad job, and so now it's time for the air sealing and insulation retrofits to correct those air sealing mistakes or the lack thereof. And so you treat these staircase walls as a knee wall, and so you make sure that the bottom and the top area has an air barrier and that it's been air sealed. So many older homes have a actual real tongue and groove ceiling and not just a decorative tongue and groove ceiling. So every single one of those tongue and grooves is a source of air leakage. And so then, it's how would you air seal this? And a good way is to actually use a can of what's called a froth pack. And if you don't have a spray foam rig on the truck, then you can actually purchase, if you're a company or even a DIYer, purchase what's called a froth pack. And it's a pack of insulation foam that is about the size of a barbecue cylinder, and it comes with a spray gun, and you can spray like an inch or half an inch of foam onto the tongue groove ceiling, and then that completely seals the tongue groove ceiling, and then therefore insulation can be blown on top of this and be effective insulation. Storage platforms, oftentimes, the decking's already there. There's already, the Christmas and Halloween supplies and a bunch of other, storage stuff. And so the desire is not to disassemble the storage platform in order to insulate underneath. So one good way of insulating underneath a storage platform is to block it with fiberglass bats, and then that will prevent the insulation that's blown from blowing out the other side. And so then you can actually dense pack underneath the storage platform to get the maximum insulation underneath these storage platforms. So this was a way to prep that attic storage platform before you blow the insulation underneath. And then once you get to this step, you've probably covered all the major critical details in an attic. So, we want to see a photo of general overview of the attic before insulation goes in. And then the attic access. Oftentimes, you'll find that if the attic had insulation in the past, the insulation will actually start to become less and less as you get towards the attic access, because they did not build an attic access dam to enable the full depth of insulation to be installed right up against the attic access. And the correct way to do it is to install a insulation dam so that you can get the full depth of insulation all the way up to the attic access. And of course, it's good before you blow in insulation to put in the weather stripping, because when you blow in insulation, it's very dusty and everything. And so then the adhesive on the weather stripping can not stick correctly. And so before you get all dusty, it's a good idea to put your attic weather stripping at this step of the process. Then on the insulation step, then we want to see a photo of the attic rulers, which tell you kind of and direct and how much and where. Because when you're blowing insulation in an attic, it's not very easy to tell. Like, have you blown enough in this area, or do you still need to blow more? And these rulers have indicators to tell you. And we also want to see a photo of the measuring rules, because once in a while, not saying anybody would do it, but it has happened. Insulation companies will actually try to cheat and bend the ruler down to make it look like you blew in more insulation than you actually did. And so getting a photo of the attic rulers before insulation goes in is a way to avoid this issue. We also want to see kind of the instructions on the blown in insulation bags, because different companies may have different instructions on how many bags need to be blown in order to achieve the determined desired R value. So we want to make sure we see that. Skylight shafts, again, like these are the areas that are hard to insulate and sometimes not insulated well. So that's why we want to see photos specifically of those areas. So skylight shaft insulated, knee wall insulated, stairwell insulated, storage platform insulated. And so once you get all the difficult insulate areas, then you can show the wide angle photo. This is the one that's like, everybody wants to show this part, look how nice we did our attic. Yeah, did you do those difficult parts well? So we want both those photos and this photo. And then it's really important that the attic access get as much insulation as the rest of the attic, because otherwise it's like a hole drilled into a bucket. The water will leave through the hole and nowhere else. And so that's why you want to make sure that there's no thermal bridge or an area with no or low amount of insulation. So then, you've done the attic air sealing, you've done the insulation, and now you should be able to, when you do your blower door again, see a big difference. And so how big of a difference do we make? We want to measure that. So that's why we want a blower door test done after the attic air sealing insulation work. And then here's a photo, some screenshots of what these photo reports look like. As you can see, all the photos are properly sized and placed into the reports. And we've got a few minutes to speed through the heat pump ducted workflow. You can always go back and look at these workflows yourself and look at the requirements, but we'll speed through these. So heat pump ducted workflow. We want to assess the ducts because, as I said before, it does no good to install a high-performance heat pump into garbage ducts. And so we want the first part of evaluating a duct is to get a visual assessment of the ducts, but visual assessment doesn't tell you everything. You also want to then measure the performance of ducts. And so there's 3 indicators for a duct performance. Static pressure, which is kind of like the blood pressure. Like if you go to a doctor, they measure blood pressure. That measures how hard your heart needs to pump in order to move blood around your body. Same thing, static pressure measures how difficult or easy it is for the air handler to blow air for those ducts. We also want to measure airflow, which is to measure, besides how hard it needs to work in order to push that air, we also want to measure how much air actually moves through the ducts. And so that measurement helps you understand, okay, well, what is the capability of these ducts? Because if you install a heat pump into ducts that are, like, for example, if you install a 3-ton heat pump, but your ducts are only really capable of 2 tons, then your 3-ton heat pump will perform at best to 2-ton level of performance. And so that's why you want to measure airflow and then duct leakage. So duct leakage is like, throwing money out of your house if your ducts are outside a conditioned space. And so we want to know what level of leakage there is. And if the leakage level is really high, then you obviously want to fix those leaks because, it does no good to pay money and then have to heat and cool the air and then have it just escape. And so those 3 measurements kind of help you understand as a contractor how good or bad those ducts are. And so that's important because you want to have that conversation with the customer. And you as the customer, you don't want to pay for a heat pump that isn't going to perform well. So you also want to think about, the quality of your ducts as well. And the only way you know is by measuring. And that's why those assessment of the duct photos and the test described were there. And then after you understand the ducts, you also want to know where you want to put your outdoor unit. When you put your outdoor unit, you want to think about snow and, protecting the outdoor unit from snow because, if you're going to use your heat pump in the wintertime, there's a chance that, it might snow and you don't want it to be buried in snow because otherwise it's not going to work. And so you want to think about what the, typical level of snow depth is, on the side of your house in the area where you want to install your heat pump. And you want to elevate it if it's going to, be an area that does get snow with either a wall mount or a ground stand. And then if there's any protective covering over the heat pump, such as an awning or cover, then, that might, if you have an awning big enough, you might not need to put it on the stand because that awning might protect the area enough from snow that's not an issue. So just things to think about, and that you're documenting what the heck the thought process is or the decisions that are being made. Manual J is a important calculation. It's a load calculation. It's a process for understanding how much heating and cooling load that your home needs on the hottest and coldest day out of the year. And so how that is determined is by measuring the level of insulation and the quality of your windows and the size of your home and running that all through a calculator. And so there's different calculators that are acceptable. ACA is a organization that keeps track of what the acceptable calculators are. Here's a list of them. In addition to that, here in the Pacific Northwest, there is a free tool that's been created called HVAC sizing tool that's released by Better Built Northwest. It's free for everyone to use. You can just sign up for an account, and it's free to sign up for an account, and then you can do manual J's, and it's encourage your HVAC contractor to use this tool if they're not already using a paid software like RightSoft or Elite. For duct design, there's a tool called Quickie Model. And so this tool runs on a game engine, so it makes it kind of easy to point and click and drag and design high quality ducts that way, and makes it easy. This tool also has a manual J calculator built in for also sizing the heat pump in addition to designing ducts. Some programs might allow other tools to be used besides the ones on this list. And so once you have the, what the heating cooling loads is for the home, then of course we want to then pick a heat pump that can meet those loads. And the way you pick a heat pump then is, you can look at the manufacturer's heating performance tables, or NEAP also has a nice database of performance specifications of different heat pumps. So that's the screenshot of the NEAP website. But here's another example of a manufacturer's performance table. And here's another one. Different manufacturers have different ways of displaying the performance tables. And then cooling performance. Of course, we care about summer. Sometimes in these extreme hot days, we care about cooling performance too. So we want to look at cooling performance tables. And so that is, those help you determine and pick your heat pump. And then afterwards, then if the heat pump is going to replace a air conditioner or an older heat pump, then one of the things we want to do is be responsible stewards of the environment. And so the refrigerant from the old heat pump needs to be removed in a safe manner. And so there's some prompts here to document that that was done. So the nameplate of the old heat pump, the refrigerant recovery setup, and then how much refrigerant came out of the old system. And that's a good way to document that, it was responsibly, taken care of. And then, of course, if we picked a heat pump, did the right heat pump arrive at your job site? We want to take a picture of those nameplates to make sure that, the right one showed up at the door. And so same thing with the indoor unit. We want to make sure that it's powered with the correct circuit breakers. And sometimes the circuit breakers are actually integrated between the outdoor and indoor units, so then you can indicate that. These are very important tests to make sure that your new heat pump won't require refrigerant topping up later down the road. So this is a pressure test to make sure that there's no leaks and that the connections that are made can handle the highest pressures that the system will ever encounter in operation. So test at the highest pressure, make sure there's no leaks. Want to make sure that there's no moisture in any of the pipes that are open to the atmosphere, because that moisture will turn into an acid that will then destroy the inside of a heat pump. So we want to make sure that all that moisture is removed and using a vacuum pump, and that the test results shows that there's no moisture by maintaining a less than 500 micron vacuum for at least 15 minutes. And so this is documentation of that test. If you have very, very long line sets, then you need to actually add some more refrigerant to compensate for long line sets, such as, for example, this heat pump here has a factory charge that's good for 25 feet of line set. But, if you have a 2-story home and your heat pump is on one side of the house, but then your air handler is on the other side of the house, you might need to run more than 25 feet. In this case, they tell you how much additional refrigerant you need to add per foot. And so then there's a way to calculate that using the calculator built into this quality install tool. In this case, this install, we needed 0 additional ounces of refrigerant, but you can sometimes need a few ounces there. Of course, the line set should be protected from weed whackers and soccer balls and all the dangers of the real world to prevent refrigerant leaks and UV damage. And so then we want a photo showing that the line set has been properly protected. And of course, most heat pumps today are run on computer control boards, and those computer chips on those boards are sensitive to electrical surges. So it's good practice to put an electrical surge protector on a new install. In order to start up a heat pump, you need to access what's called the service ports. And so they come with service caps. And these service caps, when the technician is working on the heat pump, they put them in their pockets. But sometimes they drive off with these caps in their pockets still. So we want to document and make sure that these caps are installed, reinstalled and tight. They are part of the total system to prevent leaks. You definitely want these caps back on. And then if ducted heat pumps often require changing out the cabinets. And so we want to make sure that the ducts and the plenum on the supply and return side are properly air sealed and insulated to the new air handler. So we want a photo documentation of that. For example, here's one where, oopsies, yeah, we air sealed by taping all those connections, but we forgot to do the bottom ones. So please come back and do the bottom. And then once the new heat pump is installed, we want to measure the airflow. I showed one way to measure the airflow using what's called a true flow plate. Here's another way to measure airflow using a manometer. And you measure the static pressure of the supply and return. And then there you go, supply and return added together. And then most heat pumps have what's called a fan curve table. And then you can look up on these tables the static pressure, and then that'll tell you what the airflow rate is based on the static pressure measured. And so that's another way to measure airflow. And of course, we want to measure static pressure. And that's the reason why is because static pressure is like the blood pressure in your body. We want to make sure that the fan does not need to work super hard in order to pump this air through the ducts. And we want to make sure the thermostat settings are set correctly. And some of these thermostat settings are what's called installer settings. They're buried in the thermostat, and they're really not intended for the customer, to mess with. And so the contractor will make certain decisions on the thermostat settings, and it's good that they document these installer settings. And so here's some information about how to get accurate geolocations. The main way to do it is to just take the pictures while you're on site. You know, don't try to take the photos with your phone's camera using the camera app, and then try to upload the photos to this quality install tool after the fact, because then the whole point of the quality install tool is to have the photo prompts in front of you to direct you to on what photos to take, and you don't need to try to memorize all those photo prompts and take the correct photos and then upload them later. Why make it harder for yourself? So the most important, easy way to get accurate geolocation timestamps is just take the photos using the quality install tool while you're on site. And there's a way to check the geolocation by clicking the URL at the geolocation on the reports. And also, if you got questions about the quality install tool, or just if you need some advice on energy efficiency retrofits on your home, you can email me at edward.louie@pnnl.gov. And that's all I have for this presentation. And we are at the hour, but I can stay and take some questions if there are any. Holy moly, we got some questions. This is good. Okay, let's see. Questions. Just had to remind contractors to air seal holes in ceiling before reblowing cellulose after a fire. Paid for extra 12 inches, but they took their stick, leaving 8 bales in the truck. So stupid and inefficient. Yep, this stuff happens all the time. So that's why we're really recommending customers ask their contractor to use the quality install tool, and for contractors who are honest and want to do a good job, to use the quality install tool, because proof is possible if you take photos. Why can't they do it right the first time? After all, we're paying top dollars for professionals. Well, unfortunately, a lot of customers, they don't know one bid from the other. They just pick the lowest cost bid after getting 3 bids. And so if they're not able to, if the contractor who has the higher bid can't prove or demonstrate to the customer that they're actually doing more work and doing higher quality work, then, and the customers don't understand that, then it's a race to the bottom for lowest bid. And that's the problem. We want to make sure that everybody is bidding on the correct apples to apples bill of goods. And so by having test in, test out blower door and doing all these tests to ensure the heat pump is installed correctly and not installing to bad ducts, then that results in everybody bidding on the same kind of scope of work. Are roofers and solar installers covered? We've been asked this question before, and right now we don't have a workflow for roofing and solar installers, but we have gotten requests, so therefore it potentially is in the roadmap to create a quality install workflow for solar installations, because we have heard also horror stories of solar installations that have gone wrong. So we'll work on that. When was the tool developed? What program contractor using it now? Talk about using it. So the tool was developed over the course of 3 years, but it's now gotten to the point where it's gone from beta versions of the tool to being a tool and a version that we feel very good about having contractors use it. What programs and contractors using it? So the Inflation Reduction Act is really pushing the use of this tool. And so there are whole states that are now requiring heat pumps to be installed using the quality install tool. The state of California, for example, just announced that they're having all heat pumps in residential systems use the quality install tool. So a number of other states have done the same thing. So it's kind of getting to a point where it's a big deal. What was your role in creating this program? So I was a rater verifier for Energy Trust of Oregon, actually, for the Energy Performance Score program, EPS program in new construction. And at the time, I really wished I had a tool like this to make it standard for taking photos of the things that I needed to verify. That tool did not exist. And then after I left that job and continued to work with friends and family on energy efficiency upgrades and hearing all the not so great stories from contractors that they had experience with, and then being someone who knows how to test homes with blower doors and duct leakage testers and thermal imaging cameras, I go back into these homes that my friend tells me that they got an energy efficiency retrofit on, and then I find that it's really not that high quality. They missed all these spots. That's the motivation for working at the Pacific Northwest National Lab with my team to create this tool so that the next millions of homes that get energy efficiency upgrades will do it right the first time. Let's see. Why would a hyperheat heat pump not qualify for rebates when standard heat pump would, even though it doesn't meet the load and require backup fossil fuel furnace? I don't know. This is a question that maybe you can email me, and then I can look at the specific specifications and discuss that more with you. So yes, we also want to do a plug for the next Green Energy Series, which is December 7th. It's going to talk about the used electric vehicle federal tax credit. Right now, there's a $4,000 or 30% up to $4,000 instant rebate for used electric vehicles. And there are some income qualification requirements, but they will get into the income thresholds, and actually it's quite generous, so quite a few people will qualify. And so we'll get into that on December 7th. And I think that's all the questions that we have. So if you have more questions, feel free to email me. And this webinar will be posted onto YouTube in about 2 weeks. So if you missed it, feel free to go back and review this video afterwards. Thank you, everybody, for attending, and we look forward to seeing you December 7th for the next Green Energy Series. Take care, everybody.